So this is the limiting reactant worksheets. There are two different ideas that you need to understand. First, the first word limiting reactant, which is the one that we run out first in a chemical reaction. And the other reactant will be excess, which is left over after reaction comes to a completion. Okay, so let's go ahead and interpret this chemical equation. So what it means is that aluminum reacts with hydrobromic acid, which is acid. You're gonna learn about why this is an acid later. And induced to the product of aluminum bromide and hydrogen gas. So basically, we have to understand how to balance chemical equation first. So basically, when you see addition, that's when you add these two elements together. And this means equal. So the number of atoms on the left side, which is the reactants, has to be equal to the number of atoms at the product. So it has to be equal. So let's first go ahead and look at the one on the product because it has more numbers. So first, look at bromine over here. How many bromine do you have? 3. How many do you have over there? 1. So is there any way you can put it, you can make this into 3 bromine? First, let's try this one. Go ahead and do 3. So that gives you how many hydrogen? 3 hydrogen, 3 bromine. Right here, how many hydrogen do you have? You have 2 right here. You have 2 and 3. What are the common denominator? Is 6. So basically, what if I change my number into a 3 here? So that make my hydrogen gas, hydrogen, 6 different atoms. So therefore, I have to put 6 here just to make my hydrogen the same. So now that I have 6 hydrogen here. Now look at my bromine, because you're going to have to use a coefficient to multiply into the number of atoms. So we have basically 6 different number of bromine atoms. How many do we have here? We have 3 here, so therefore we must put 2 here, and that makes aluminum 2. Therefore we need to put 2 there. So our balanced chemical equation, we have 2, 6, 2, 3. Those are the number of the coefficient that will be used in the chemical reaction, which is the mole ratio in just a minute. So at this point, I want you to go ahead and think about what we did to get those numbers, because those are the first things that we have to do. So now you're going to go ahead and look at question number 1. So question number 1A, it says that when 3.22 moles of aluminum reacts with 4.96 mole of hydrobromic acids. So we're going to go ahead and look at the starting material. Those are 2 reactants that we have. So go ahead and write down what you have. 3.22. You must write exactly just like what I do here, of aluminum. That's what we have to start with. And then what is the other one? Let me look. It's a 4.96 mole of hydrochloric acid. What you can start with, we put on the top left. So now we're going to use the mole ratio to figure out which one is the smallest one. So we're going to go ahead and multiply this one by mole of aluminum. This one also, okay, same thing, mole of aluminum, just to get more ratio. So when you look back over here, how many different mole of aluminum do we have to start with? We have 2. And these 2 mole, you're going to have to take that into consideration because we want the number of mole in the simplest form, which is 1 mole. So we need to divide this one by 2. So the coefficient you need to you can either do multiplication by 1/2 or you can divide by 2. It's the same thing. Over here too, mole of this one right here. You write out the same thing. So we're gonna take the mole ratio into consideration. It's 6 moles right here. So we only want 1, so therefore we need to divided by 6. So that should give me 2 different number of mole. Let's go ahead and double check with the calculations. As you can see, this one is easier since we're not taking molar mass into considerations. So for the next video, it's going to be more complex, which I would call advanced one, where you would actually have to convert the grams to mole first, and then you will follow this process to figure out which one is the limiting reactant, which one is the excess. So 3.22 divided by 2, that gives me 1.61 mole of aluminum. And then do the other one, 4.96. Basically, we can cancel this one out. The only units you have is mole of aluminum, which is exactly the same thing. Divide by 6, and that should give me 0.826 mole. We only want 3 significant numbers, that's why I want 3. So now, let's go back to our definition of limiting reactant and excess reactant. Okay. You all know that the limiting reactant will run out first, which by all means that we can't really predict, we can't really tell from this chemical reaction because we do not know which one runs out first. But from our mole ratio, the mole concept and stoichiometry, we can determine which one will run out first, which is the smallest one. So the smallest one will always become limiting reactant, and that will dictate how much of the product it will be formed. So therefore, we will exclude this one for now. We will only focus on the limiting reactant one to answer the second questions. Oh, by the way, we already determined the second question. The answer of the second question, which is which one is the limiting reactants, which is this one. Therefore, the other one would be excess reactants, which we left. We have some amount left during chemical process. As you can see, I have a table one right here. It will be the same thing. So after you understand what's going on over here, I'm gonna convert that into a table form. So that would look just like that one. So now you have your table just like what you're supposed to be doing over here on the right hand side. So now just look at the last one. Well, for the reactants in excess, how many moles are left over at the end of the chemical reaction? So in order for us to know how many moles are left, we have to use the use limiting reactant to predict either product form or reactant used in chemical reaction. It will be the same thing. I'm just going to show you that it is the same pattern. So first, you will always start with your table. Since this is only one step process, you will just gonna go ahead and put whatever the limiting here on the left, which is this. You will write down more of just like what it says. This one, because this one is the limiting reactants. So on over here, right? Remember our purpose of this one is to cancel unit out. So this one will always be the limiting. Also, you will write down like more of HBr, which is the limiting reactants. And then you also write down mole because they're looking for mole. Even though if they look for grams, you're gonna have to do the mole to gram first, anyways. So you're gonna go ahead and have to. They ask you how many mole are left over at the end of the chemical reaction. So we're gonna go ahead and take this aluminum into consideration because we're talking about how many moles of the reactants are left over. So now we're gonna use the number of the coefficient right here. Go back to your chemical equation, which is the balanced one only. We have 2 moles of aluminum, so I'm going to put 2 moles there. How many moles of HBr do we have? 6. So I'm just going to put 6. So let's cancel this one out. So the only thing I'm looking for is So now I would have this multiplied by 2 divided by 6, so that should give me some answer. Let's double check this one real quick. 10 divided by 6, so that should give me mole of what? Aluminum. So in order for us to determine how much or how many moles are left over, we're gonna have to start out with what we have. I'll be right back. Okay, we start out with what we have, which is from the question that is telling you. So basically we have to determine how many moles are left over. So we have this, subtract by the one that's being used. So therefore, I do the math. And that should give me this one. Oh, I give 3 significant numbers, that would be 2.95 mole of aluminum left over after chemical reaction comes to completion. So basically, I just give you how to solve number 1, so you should be able to do the rest of the activity